Hey, good day, fellow. Seto is back. Today we are going to discuss this topic of intermolecular and intraatomic forces. Before I can even start with those two concepts, let me firstly highlight the most important concept. Firstly, as a learner, you need to know the polar molecules. We have polar molecules. You see, what are those? Then as for polar molecules, are those molecules which are not symmetrical. Do you understand? Those molecules which are not symmetrical. The example that I can give you is HF. See, hydrogen fluoride. See, we know that fluoride, it is more electronegativity compared to hydrogen, meaning it has an ability to draw electrons closer to itself. Somehow it's going to be slightly negative, then hydrogen is going to be slightly positive. From this, we can see that these two, they are not symmetrical. This side we have what? We have hydrogen, which is positive, slightly positive. This one, which is slightly negative. You see, we say such molecules, they are dipole. You see, molecules, meaning they consist of two poles. Yes, which is positive and negative. The number two, we have non-polar molecules. What are those? Molecules which are symmetrical. Do you understand? The example that I can give, all diatomic molecules such as hydrogen. See, hydrogen, they are non-polar. Why? Because they are symmetrical, meaning the electrons, they are evenly spread around these two. Do you understand? The electrons, they are evenly spread around two. Another example that I can give that you must know as well is methane, CH4. Such molecules, we say they are non-polar. Why? Because they are symmetrical. You see, if I were to draw the structural formula for this, we can see that this molecule is symmetrical. Do you understand? Another example that I can give for polar is H2O, NH3. See? Then okay, let me move now to ionic compounds. We have ionic compounds. Ionic compound. What are those now? You just need to know, that ionic compounds, they consist of metal and non-metal. You see, this one, it has to do with the transfer of electrons between metal and non-metal. An example that I can give is sodium chloride, which is a metal. This one is a non-metal. You see, they consist, these ones, they consist of complete charges. Do you understand? They consist of complete, complete, some they say complete full charges, like this, meaning we know if these two dissociate, we can get something like this. You see, we have a full charges, then we say ions as well. You see, we get something like this. This side, we get something like this. On this one, the polar electrons not spread evenly. Then this side, electrons, they are spread. Electron spread evenly. Do you understand? Now, let us consider now these two concepts, the intermolecular force and interatomic force. Then we have intermolecular force. What do we mean by this concept now? It's a force between atoms. Do you understand? Let me give you an example using a sketch. We saw there that HF, let's say HF like this. We saw that this one, it is slightly positive, and this one is slightly negative, meaning most of the electrons, they are attracted to fluoride. Why? Because it is more electronegativity compared to hydrogen. Then if I were to take, let's say, another HCF like this and place it next to this one, what is going to happen? We know that unlike charges, let's say positive together with negative, they do what? They attract. Do you understand? Meaning the fluoride, this slightly negative, you see, is going to be attracted to this slightly positive. Do you understand? Somehow, let me just write it like this. Let me just write it like this. Let me do like this to make things, you see, slightly negative. And you see, like this, meaning, sorry there, this one is going to be attracted to this, then this is going to be attracted to this. You see, opposite charges attract. Do you understand? Then this force, we say it's intermolecular force between charges. Do you understand? Then we also have now an intraatomic force. This one is a force within atom. Some say molecule, which is now this, between this molecule. Do you see this molecule? Now within this is going to be intraatomic force. Do you understand? This one is within an atom or a molecule. Do you understand? Now, what I'm going to do is I'm going to do the type now of intermolecular forces. Then let me erase. Okay. The types of intermolecular force that a learner must know. These ones. See, type of intermolecular forces. Intermolecular forces. Do you understand? I'm going to take a polar molecule. Let me see. Polar molecule, keep that in mind. Then together with a polar molecule. Don't forget that we said polar molecules, they are dipole. Keep that in mind. They are dipole. You see? It's like now I combine a dipole together with a dipole. I'm going to get what now? If I combine a dipole together with a dipole, then in that case I'm going to get a dipole dipole force, like this. Do you understand? Then we call this intermolecular force if we take two polar molecules and let's say combine them together. We get a dipole force. Do you understand? Like this. Then now, what is going to happen if I decide to take a nonpolar now? Nonpolar together with a nonpolar. Nonpolar together with a nonpolar. Then in this regard, we get an induced dipole. Do you understand? Induced dipole, or somehow they call these ones London forces. Do you understand? Induced dipole. Then, now what is going to happen if we take a polar together with a non-polar? You see, we are going to get now a dipole, induced dipole. You see, we have this way. Let me try to explain this concept. An induced dipole. You understand? We have now this new concept of induced dipole. What does this concept implies? What does this concept implies to us? We know that as for nonpolar, let me just draw a simple sketch like this. We know that as for nonpolar, the electrons, they are evenly spread. Let me do like this. Let me do like this. As for nonpolar, the electrons, they are evenly spread like this. There are situations whereby there is some situation whereby, let's say that atom undergoes some change, you see, but temporarily so. You see, you'll find that the electrons will be more on one side. Like this, you see, when we get a situation which is like this side will be slightly positive, then this one will be slightly negative. It's like if I were to expose another one, let's say another form. Let me say if I have an ion over there, an ion Na like this, you see, then this one is going to be attracted to this. Do you understand? Because this is positive and this, they are negative. You see, it is induced dipole for a moment. You see, it is induced dipole. We get a situation whereby now this side it is slightly negative and this one it is slightly positive, just for a moment. Hence we say nonpolar undergo induced dipole. Then what is going to happen if we take a polar together with a nonpolar? As for polar, we know polar molecules, they are dipole, meaning they exist like this. You see, they exist like this. One side is slightly positive, the other side is slightly negative. Then when we take a polar together with a nonpolar, we get dipole, induced dipole, dipole, induced dipole, like this. You understand? And now I'm going to take ion. Ion, they consist of complete charges like Na like this or Cl like this. See, ions, or let me just say ion. If I decide to take a polar together with ion, what I'm going to get now, I'm going to get an ion dipole. Keep that in mind. Ion dipole. Then if I take nonpolar together with an ion, I get an ion induced, nonpolar induced dipole. Like in this situation, I have an ion Here I have an induced dipole. We get ion-induced dipole, ion-induced dipole. Do you understand? Then another form that I just want to add to the list, it is a special type of polar and polar molecule, which is hydrogen bond. This one, it is so special, you see, hence we call it an hydrogen bond. If we take two polar molecules, but I'm going to explain it, and hydrogen bond, you understand? This one is a special type of intermolecular force. It takes place only if or only when hydrogen interact with the following, with either, I call it with north, north. There's a reason why I say north like this. You see, when it interacts with nitrogen, oxygen, my apology about noise outside, or fluoride, like this. Do you understand? Let me give you a picture. We get a situation now which is like this. Let me take H2O for an example. Do you understand? Let me take H2O over here. Let's say if I have H, noise like this. Do you understand? Then I decide to place another H2O over here. Do you understand? What is going to happen? Sorry. We know that oxygen is slightly negative. This one is slightly positive, slightly positive, slightly negative. This one is slightly positive, and this one is slightly positive. Do you see negative and positive? They are going to interact like this. You see? Then we call this intermolecular force between OH. What? Hydrogen bond. Do you understand? Again, if we have HF like this, let me do this one like this. We know that this one is slightly negative, this one is slightly positive, this one is slightly negative, this one is slightly positive. This force between H and F, we call it hydrogen bond. It is so special to understand. Or again, if I take now, let's say if I were to take now nitrogen, NH3, let's say something like this, and place another one over there, something like this. This one is going to be slightly negative, and this one slightly negative. Our H's, they are going to be slightly positive. But now this negative is going to be attracted to that H. You see, whenever hydrogen is attracted to either nitrogen, oxygen, or fluoride, then what is going to happen is we are going to get this special force, which is known as hydrogen bond. Do you understand? Then lastly, we just need to know that, okay, I don't have much space. Let me erase. Lastly, we just need to know that as for intermolecular force, we have the weakest, we also have the strongest. Do you understand? Then the weakest is going to be London force or induced dipole. You understand? Or let me write, or some they call London force. London force. Like this. It's going to be the weakest. Then follows dipole, 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 follows hydrogen bond, hydrogen bond. Do you understand? Then you get an ion induced, dipole. Do you understand? Lastly, we get an ion dipole, like this. You see? Then let's say if I were to give you, let's say these two, I say we have H2O and let's say hydrogen. Then I ask you this question: which one between the two has the highest, let's say, boiling point? How will you answer that question? Between the two has the highest boiling point. Then, to approach this question, you just need to ask yourself this question. Then, what are the forces, the intermolecular force that H2O possesses? Do you understand? Then we have H2O. It's like if I were to take two H2O in my mind, H2O, let's say with another H2O there. Oh, I see that I'm going to get what? The hydrogen bond, which is somewhere here. Let me put a dot. Then on this one, I know that this one is a non-polar, this one is a polar, which means I'm going to get the hydrogen bond. Then we also find the dipole, we also find the induced dipole, but the dominating one is going to be the hydrogen bond. Then on this one is going to form the London forces. You see, this one is going to form London forces. Then this one is going to form hydrogen bond in between. Then from this, now we can make a conclusion by saying H2O is going to have a higher boiling point. Why? because the hydrogen bond, they are stronger than the London forces. You see, H2O is going to have a higher boiling point. Let me write it. H2O is going, sorry, to have high boiling point. Why? Because hydrogen bond, because of hydrogen bond, which are stronger than London forces of hydrogen, like this. Do you understand? Then this is how we answer these questions. You see? Then now, if I were to ask you now this question, let me raise again. Let's say if I were to take HF together and let's say sodium chloride, like this. Then I ask you this question now to say, determine the intermolecular force that is going to exist between the two. Now, you see, I'm not asking you which is going to form a stronger intermolecular force. Then, what intermolecular force is going to exist between the two? How to approach this question? Then, HF, we know that this one is a polar. Okay, this one is an ionic compound. Then for this one, we know a polar, all polar, in fact, they are dipole. They consist of two poles. Do you understand? Then now what is going to happen if I take a dipole together with an ion? This one is going to form an ion. It's clear that I'm going to get what? An ion dipole. Do you understand? An ion dipole. Then the force that is going to exist between the two is going to be ion dipole. Do you understand? If I were to draw a sketch, somehow, you see, it will be something like this. We know that this one dissociate, you see, then we are going to get a situation which is like this. The positive charge of this is going to be attracted to, let me do like this. Sorry, it's going to be attracted to the slightly negative of fluoride, like this. Then this negative is going to be attracted to slightly positive of H, like this. Do you understand? Like this. Then okay, yeah, just like this. I think like I have explained almost everything regarding intermolecular force and intra-atomic forces. Then I thank you and enjoy your day.